Okay, I hope the screen is visible to you all. Okay, so there will be a lot of images like this of sun. Okay, and oh, just a second. This is not your slide. Yeah, it's your slide. Okay, now let's go. Now let's go one by one. Let's see the size of the sun at first. And as you know, when compared with the size of the planets, okay, the sun is so huge. You can see this is the compared size between the sun and the planets in the solar system. You can see this Earth is so small when compared with the size of the sun. Okay, so in the solar system we may think that the planets are of comparable size, or in photos and all we see that Earth is pretty big when compared with the not big, maybe which is not that small like this. That was the notion we had, but when you compare it side by side, this is the reality. And the size of that Earth is, you can see that it is wow, okay, 1,391,000. Okay, we can see that this much is the one. Okay, 30,91,000 kilometer is the size of Earth. That is, if you measure the size, that is from one side to the other side, if you draw a line through the center, and the size of that line is approximately this, and this is called the diameter or the size of the sun. Okay, and if you calculate another interesting thing regarding the volume of the sun, so imagine it as a imagine the sun as a big sphere. Okay, it's a big huge sphere, and it is a transparent sphere. Assume that it is a sphere like this. Okay, and then we can put almost this much. Okay, this is some 13 lakh. Okay, so 13 lakh Earth can be put, or 1.3 million Earths can be put inside the sun. Okay, so if you start to drop one by one Earth inside to fill inside the sun, it is anyway not possible, but we are assuming to see the size, then we can put this much number of Earths into the inside the sun. Okay, so that is how it works. So that huge the sun is when compared with the size of Earth. Now regarding the mass of the sun, okay, so sun is approximately 333,000 times the mass of Earth. So if you compare again, so instead of saying the kilogram, it is always better to learn the size of things based on something what we know. Okay, suppose if you want to say the size of we already, okay, so you know that if you want to say the size of a person, or size of an elephant, we can say that it is 2 times taller than a man. Okay, or 3 times taller than a child. So that is one way of saying the size of things. Okay, compare it with something that we know. So when we compare the size of Earth, okay, you can see that the volume, you can see that 1.3 million Earths can be filled inside the sun. And similarly, if you take the mass, or simply if you call it as the weight of the sun, but more properly we have to call it as the mass, is approximately 333,000 times the mass of the Earth. Okay, it is 330. So take the mass of Earth and multiply it with the 333 times. Or in other way, we can say that if you have a weighing balance, I don't know whether you know this kind of balance. Okay, okay, this is called the common balance. Okay, something like this. Okay, and it will be hanging from here. And if the top rod is parallel, that means both the weight in this ball and in this ball are the same. This will be parallel. If it is slightly slanting towards one side, this is is heavier, and this is light. I hope you know. So if you place sun here, okay, if you place sun inside this, then you have to place 333,000 Earths. Okay, not just one Earth. You have to place 333,000 Earths here. 1, 2, 3. Like you have to fill it with so many Earths. Okay, so that then only it get balanced. Okay, so that much earth is needed to balance the weight of the sun. If you assume that it is on it, this balance is called, or this weighing machine is usually called the common balance. Okay, now if you write it as a number, okay, you can see that it is written as 198. You can read the number of zeros, almost 27 zeros are there. Okay, so this much kilogram is the actual weight of the sun. So instead of by hearting this number or understanding this number, you can imagine it as how many times it is much heavier than the earth. That is one way. And I will, since you are all junior students, I will teach you another interesting thing to write this kind of numbers into small digits. Okay, for example, just leave all this. So suppose if you want to not about this number, uh, when you go through slides, maybe even my slides and all, you will see some numbers like 10 to the power 5. Okay, so what is the meaning of this? Or usually we write numbers like this, okay, all along a line. But sometimes in mathematics, actually we write numbers like one number and the other number will be written here as a small number, okay, in this bracket. So 10 raised to 3, 10 raised to 22, 10 raised to 5. So what is the meaning of that? Okay, what is the purpose of that? So the purpose of that is, suppose you want to write, okay, this is 1 lakh or 100,000. How many zeros it has? 1, 2, 3, 4, 5. So you have to write 3 and 3. That is total 6 digits that you have to write. So instead of this, you can simply write this as, first write the 10. Okay, so it applicable for numbers starting with 1 and 1 and remaining 0. It's also applicable for any kind of big numbers, but I am only explaining this simple method to write the multiples of not the multiples, the numbers like this, 1 followed by zeros. So those numbers can be written like this. So instead of writing this 1 followed by 5 zeros, first write 10, then count the number of zeros. How many zeros are there? 1, 2, 3, 4, 5. So I can write like this. So 10, this is read, you can read it as 10 raised to 5. Okay, just leave that reading and all. You will learn all these things in your school classes. Don't worry about this. I am just mentioning it because when you go through this slide, you will see these numbers, this kind of writing somewhere. So just to avoid the confusion, I am explaining you that. Okay, so then I am writing a number. You have to write the answer in the chat. Okay, so how can I write this number as a long digit? Can you put the answer in the chat? Answers are coming. Yeah, let me count the zeros. How many? 1, yeah, 3. Yes, yes. Almost all of them are getting it right. Yeah. So that is 1 followed by how many zeros? 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, so this is how you can write it. Okay, so this is the way of writing. Now just imagine what is the weight of sun. So instead of writing the weight of sun like this big number, okay, this is always inconvenient, especially if, suppose you are copying down this from my note or from my slides. The problem is that you have to keep the count of zeros, and especially this is a series of zeros trailing, then it is not that easy to keep track of them and you can exactly copy them. So when you copy down those numbers, it will be so difficult for you. So there is a simple method for that. That is why scientists use this kind of method for writing numbers to avoid the confusions. Okay, so for example, instead of this, what you can see, okay, it can be written like this. That is 1.989 into 10 to the power 30 or 10 raised to 30 kilogram. So that means 1.989 into 10 30. That means 1 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That means how many zeros it should be? That is 30 zeros. Okay, so this is one interesting way of writing numbers in scientific notation or in a special mathematical notation called exponential. So this method of number writing is called exponentials. Okay. So now let's go back to the other part of the sun. Okay, and when you look at the sun, okay, or yesterday we learned that if you analyze the light coming from the sun through what is called a prism or a spectrometer, it will split into its constituent colors, and there will be some missing dark lines that we explained yesterday, that we learned yesterday, and from those missing lines we can understand what are the material present in the sun. So initially, especially in the case of astronomy, before this person is called Cecilia Payne, okay, lived during 1900s, okay, and he is the first American to get a PhD, first woman, an American woman to get a PhD. Okay, so that is one of her specialty, and she analyzed lot of this lines that is coming from stars, especially from sun and other stars. And people at that time thought that the sun also comprises of all the materials or all the elements that are available in the earth. So earth, we have oxygen, hydrogen, every kind of iron, everything is there, or most of the periodic table elements are there in the surface in earth. And people thought that the same thing will be, the sun is also made of the same, made of those elements, and the other stars are also made of the same elements. But when Cecilia done her PhD by studying these stars, she found that even though all the elements that are seen in earth is actually available in the sun as well, but the composition, the ratio of them are different. So the most of the element, okay, or the most abundant element in the sun is actually hydrogen. If you check the mass, okay, if you weigh the sun, 73%, that means 3 by 4th of the sun weight, almost 3 by 4th of the weight of the sun is from hydrogen. And 20 quarter, okay, 1 by 4%, or not 1 by 4%, 24% or 1 by 4th of the mass of sun is helium. And other carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, almost all of them are there, but they are all so tiny fraction. So they are, we can say that they are so tiny, that is so insignificance, in the sense that the hydrogen and helium are the most abundant element in sun. So this is one thing that is a groundbreaking discovery that is made by Cecilia Payne during her PhD. Okay, so that is it. So early belief, sun and stars share the Earth's composition. So sun and other stars has the same composition as Earth. That was the early belief. But Cecilia Payne's work revealed the sun's composition is dominated by hydrogen and helium. Okay, and there is one more interesting thing. All most elements exist as atoms with a few molecules. So I haven't explained you atoms properly, so that is why I brought a video for you. I will show you that video first. I hope you can see this video. Okay, let me play this. Okay, so what we are doing in this video is that you can see an AI model lady here, and we are zooming into her hair. We are taking a hair strand and zooming into that. Okay, so here you can see initially the size was 1 centimeter. Here you can see 1 meter, 1 centimeter, 1 millimeter, then micrometer, nanometer. These are all tiny numbers, okay, or so tiny length scales. Okay? Just leave those numbers. Anyway, you just get an understanding. We are zooming into a hair strand, and then let us see what we can see. Okay, so at least you can see a hair strand that you have right now, but you cannot zoom in like this, but we are going to zoom in. Okay, see those hair strand. Okay, again keep on zooming in that small square. Now it reveals the structure. So the hair strands, we feel that it is so smooth and all, but if you zoom in, you can see that it is not that smooth. There are some structures like this. It's kind of a rough thing. Okay, you see, yeah, if you go through that, and again, okay, so this is hair and its width is written as 100 micrometer. Just leave that unit and all, but it is so tiny. That's now if you go again, you can see that how it is made. So the small pieces, actually, that is made of small pieces that you can see. That is, these are all the cell. Okay, so the hair is made of cells, and these are all the cells what you are seeing. Okay, and again, if you zoom into the cell, see, yeah, that is called macrofibrils. Okay, I don't know these things actually. These are all some biology things. Okay, then if you, yeah, you can see again small strands inside that, and if you zoom in again, okay, so still that what we are doing, actually we are actually zooming in into a hair strand. Okay, and again we can go into that. Yeah, now you can see this is the keratin. Basically, that is the compound with which the hair is made of, or one of the major compound in hair is keratin. So that is why we might have heard some kind of treatments for hair like the keratin treatment. At least some of your family members may know, or at least you might have heard that. Okay, so this is keratin, and if you zoom into the keratin, that keratin is actually made of different atoms. Okay, keratin is a molecule, and that keratin is actually made of, you can see, oxygen. This, some of these balls are actually oxygen, some of the balls are actually carbon and nitrogen and sulfur. So keratin is a molecule, but that keratin molecule, if you zoom in further, then you will see it as individual balls. So those balls are carbon, oxygen, nitrogen, sulfur, and those individual balls are actually the atoms. Okay, so they are the atoms. So we can say that if you zoom into something, anything, if you take some water and do the same thing, zoom in, zoom in, and finally you will reach at a state where you can see a water molecule. So you will say that a water molecule consists of, sorry, here I cannot write actually. Just a second. So if you zoom into water, you will see one ball like this, that is called oxygen, then two balls nearby, that is oxygen, and you won't see this line or anything. It will looks like this, too small. Okay, this is oxygen and two hydrogen. It looks like this. So we can say that the water is basically made of hydrogen and oxygen. So that is the fundamental constituent of the water, but we won't see that, okay, because it is so small. We cannot even see with the usual microscope or anything. So there are special kind of microscope to see them like this. Okay, so that is what is that is the scale at which the atoms are being. That is why we do not have you won't see it anyway, but we can see only the pictures. That is why it is not that familiar for us. So this is for the case of water, and each of these balls, you can see, these are all the, this is the oxygen, this is the hydrogen, this is the hydrogen. Now if you take the water, it is not just one hydrogen, oxygen and not just two hydrogen and oxygen. There are many. Actually it is sitting like this, again, again. So oxygen, hydrogen, hydrogen, oxygen, hydrogen, hydrogen. So there will be a huge quantity of will be there. So the number is something of the order of 1 followed by, or I will write it as 10 to the power 23. That means 1 followed by 23 zeros. That is at least that much number of things will be there in 1 gram of water. If you take some 1 or 2 grams of water, okay, then it will consist of so many molecules of water, and each of those molecules, so this is the molecule, and each of those molecules consist of hydrogen, oxygen, hydrogen. Now again we are curious, we doesn't want to stop here. We want to see what is inside that atom. What if we zoom into one of those? Okay, so let us further zoom in. Okay, now further we are zooming. So these colors are all artificial colors, okay, not real colors. Just so now we can see this is entirely a carbon atom. Okay, so this is called a carbon atom, and now we are going inside the carbon atom. So now onwards, many of these photos are actually not real pictures. So these are all the scientific pictures based on physics. So these are all diagrams based on science. Okay, now you can see. So these are something called the electrons. Actually, yesterday I told you that electrons are something like orbiting in some circular paths and all, but in reality it is not like that. But we use that method of saying that they are moving in circular path and all to make the things simple. Okay, so otherwise it is so complicated to learn this kind of an atom model, or if I introduce an atom like this to you, it is suddenly become so complicated. But when you go to very higher classes, if you specialize in chemistry or physics or even in astrophysics, then you will learn all these things in detail and in depth, and why it is shaped like this and all these things. Okay, so these are all the electrons, and this is not just one electron. These are called the electron clouds. Okay, even though there are only 8 electrons, it looks like a cloud. Okay, and there are reasons for that. I am not going to explain. And if you zoom in again to the center of that, means further into the center of that atom, then you will see something called the nucleus. You can see this is the nucleus. Okay, and that nucleus, you can see it consists of not just, okay, you can see that it consists of many things. Okay, two types of things are there. So one is in red and one is in white. So the colors are all artificially given to understand what it is, okay, to represent what it is. And the red ones are called the protons and the white ones are called the neutrons. So the atom, if you zoom into the atom, first thing you encounter is electrons. So electrons are there in an atom. And if you go to the center of an atom, there is something called a nucleus, and that nucleus consists of, yeah, this red one, that is proton, and the white one, that are neutrons. So the nucleus, the center of the atom, is made up of protons and neutrons. We can do this further zooming in, then we will see that it consists of some other things called quark and all. Just leave that. At least for you this is enough for now. So I will do the zooming in because it's an interesting video. Let's see it once again. Okay. Now this is the keratin. And in that keratin, it is made up of, yeah, carbon, oxygen, yeah, sulfur, nitrogen, etc. So now we are zooming into a carbon atom. If you zoom into the carbon atom, first thing that you see is the electrons, and then if you go to the center, you will see something called the nucleus. Okay, and that nucleus consists of two different things, that are, one is the proton, and proton, we say that it has a positive charge and the neutron doesn't have any charge, and the electrons has a negative charge. So that's okay. Now let's go back to the, okay, so what I was telling. So in the case of okay, in the case of sun, most element exist as atom with a few molecules, because the sun is so hot, its temperature is so high, so that there there is no, the molecules cannot exist there. Okay, if you make some molecules there, they will evaporate into its atoms. And one more interesting thing, there is no solid or liquid can exist in sun, because at that high temperature, all the elements, whatever solid you take there, it will be evaporated or it becomes something like a gas. Okay, and many atoms are ionized. So ionized means the atoms, as you've seen, it has electrons. So those electrons will be removed due to the high temperature. So that will have a, then when there is an absence of an electron, we call, when an electron is absent or missing from an atom, we call it as an ion. Okay, so that is the case of a sun. Okay, now let's study the structure of sun. Okay, so here you can see this is the center of the sun where some energy generation is happening. We will learn what it is happening there later, don't worry. So energy is generating not on the surface, the energy is being generated at the center, okay, at the core. Okay, we call it as the core. Okay, at the center the energy generation is happening, and that energy is that energy, that as light, it will come to the surface and then it is giving off light. Okay, so we may feel that when you observe the sun, we may feel that the energy is being generated at the surface, but not like that. The energy is being generated at the center. And you can see one more interesting thing, this part of the sun is called the photosphere. So photosphere is when you are seeing the sun, maybe at sunset or sunrise, it is not advisable to observe the sun at daytime. Okay, evening you can observe the sun, observe in the sense you can use your eye, that's all, and never look to a look sun through telescope. Okay, it is so harmful. It is not just harmful, it will burn your eye, that's simple. Okay, uh, harmful is not that kind of word enough. Suddenly within second or within a second, your eyes will be burned out. So never use a telescope for sun. But there are certain telescopes which are capable of observing sun with the proper filter and all, but that is different, not a usual telescope. Okay, so that part what we are seeing is called the photosphere. That is when there is a sunset or sunrise, you are seeing the sun as that orange thing. So that orange thing that you are seeing is actually the photosphere. Okay, so sun is not just, so like the earth, we say that earth is not just earth. Okay, that solid part, it consists of ocean, and if you go inside there is some molten iron is there at the core, and outside there is atmosphere. So you know that. Similarly, the sun also has different parts, and the thing that usually we see during a sunset or sunrise, that is just the photosphere. So that is the important. So you can see this like this. Okay, so this photosphere is the layer where the sun becomes opaque and marks the boundary past which we cannot see. So in other way, if you are looking from here, from the earth, we cannot see inside the photosphere. Okay, so where the sun becomes opaque. So even though if you zoom in or anything, but you cannot see past the photosphere. Okay, energy that emerges from this photosphere and it is coming to the earth. Okay, so and the temperature of the photosphere, I am only talking about the temperature of this photosphere, not about the center or anything. So this temperature of the photosphere is 4000 to 6500 Kelvin. So even though it looks like just 1000 Kelvin or 1000 degree, maybe it is also, if you say it in degree Celsius, okay, even though it is something around the same, okay, some 4300 or 3500 or 3700 degrees Celsius, even at that temperature nothing can exist there, nothing solid can exist there. That is why we say that we cannot go there. Okay, and you can see the approximate size when compared with the earth. Okay, so that is the solar photosphere. Now just outside the photosphere there is a layer called chromosphere. So chromo means usually color. Okay, that is one word that is used for color, and that is that just outside layer, the region of the sun atmosphere that lies immediately above the photosphere is called chromosphere. So sun's atmosphere is divided into many parts, and just above the photosphere, that atmosphere is called the chromosphere. Okay, And this chromosphere, there is a reason for this. We cannot see it usually, okay, or just with even with any kind with the usual telescope and all, we cannot see. But during a solar eclipse, okay, so during a solar eclipse, when the moon completely blocks the sun, you can see some interesting things. So near the limb or near the edge of that black circle, that is actually the moon, and you can see something like this red colored. You can see that red color, okay. So that red color, tiny thick tiny thin surface of sun is called the chromosphere, and because of that red color, it is being called the chromosphere. Nowadays, there is no need to observe there are some objects called a coronagraph or solar observatories, which is actually in the space, okay. So they can actually make artificial eclipses by covering the main part, the photosphere of the sun, using some disk, and they can actually observe. Now there is no need to wait till an eclipse to see this chromosphere. And above this chromosphere, there is another interesting thing called a corona. Corona is not a virus actually. Something that looks like a crown is actually called corona, and this is the first corona that we are all learned even before the COVID. Okay, so the chromosphere thickness is 2000 to 3000 kilometer thick. Okay, and another interesting thing, that red color is because of hydrogen. Okay, reddish color of the chromosphere, the bright red line caused by hydrogen. So why hydrogen is causing light? Yeah, the energy transfer is coming. Okay, so some electrons in the hydrogen is jumping from a higher stage to a lower energy, so that it will emit light, as we discussed yesterday. Okay. Now there is another thing. Scientists in 1868 observation of the chromospheric spectrum. That means they analyzed the light from the chromosphere and revealed a yellow emission line, and that did not correspond to any previous known element on Earth. So it was a new element, and that new element, the scientists quickly realized that they had found a new element and named helium. So helium was first found out from the chromosphere, or simply from the sun. That is why the name helium. Okay, and you can see an interesting thing. The temperature of the chromosphere is about 10,000 Kelvin. So what was the temperature of this photosphere? 4,000. So when photosphere and there is an interesting thing, chromosphere is actually just outside the photosphere, even though it is high in temperature. Okay, so usually when you, since the burning is, or the energy generation is happening at the center, as you go further away from that, the temperature should decrease. That will happen still photosphere, till photosphere, and after photosphere again the temperature will increase. So that is an interesting factor about the sun. Okay, now let's see. So above the chromosphere, this is the biggest part, one of the biggest part of sun, or biggest structure of sun, that is called a corona. Okay, and that is the outermost part of sun's atmosphere is called a corona, and corona can be observed during a total solar eclipse. You can see this white thing that you are seeing, some white cloud like thing, that is actually the corona, the atmosphere of sun, the outer part of the atmosphere. And corona extends millions of kilometers above the photosphere. Okay, it is one of the, even it is bigger than the sun. Okay, okay, now we can, usually we cannot see this because of the heavy light coming from the sun. We cannot see this, but during an eclipse this will be covered with the moon, so that we can see the corona. And its temperature is, you see, it is 3 million Kelvin. It is even outside, it is 3 million Kelvin. So the reason behind why this is happening, why this corona is so high in temperature when compared with the photosphere, that is a puzzling question for astrophysicists or solar physicists. So some astrophysicists who study sun specially, or the scientists who study sun, they are called a solar physicist. Okay, so the solar physicist, this is a puzzling question. It is why this is happening, and still there are many theories are there, and apart from these theories, the exact mechanism behind coronal heating remains an active area of research in solar physics. So still this question is not completely answered. There are still confusions out there. So that is why it is said when there is a confusion, there will be a lot of science happening there to find out what is the clear answer. Okay, so that is about the corona, and it's so interesting. And there is okay, and another thing that is coming from the sun is called the solar wind. So the solar wind is actually so important when considered with the life on Earth. So sun's atmosphere produces a stream of charged particles. So charged particle means that is protons are there, electrons are there, protons are positively charged, electrons are negatively charged. This is actually streaming out of the sun, okay, in all direction into the solar system. Okay, and they are at a speed of 400 kilometers per second, and it is actually hitting every planet, even the Earth, including every planet it is hitting, and it can cause some damage to the life on any planet. But one advantage is that, especially in the case of Earth, Earth has its own magnetic field. So that magnetic field can protect us from these charged particles. But there is a catch there. Even though Earth has a magnetic field, that magnetic field is weaker at the poles. So no, at North Pole and South Pole of Earth, this magnetic field is weaker, so that these particles can come to the atmosphere, and it cause some this kind of some bright emission of light. So something like this we can observe in the northern uh, North Pole and South Pole, or near the North Pole and South Pole, and it is called the aurora, or we call it as the northern and southern lights. So, and the reason behind that is solar wind. And one more interesting thing, whenever there is a comet, okay, so the comet dust and materials will come out, and that material will make a tail. Okay, you can see that it is making a tail, because if the sun is here, there is solar wind is coming from there, and that solar wind is blowing away all these materials, and it appears as a tail. So the reason for the comet tail is because of this solar wind. Okay, so that is, and there is an interesting factor. You can see that 1 to 2 million tons. Okay, tons means some 1,000 kilogram. Okay, so million tons of material is actually going away from the sun every second. Okay, in every second some million tons of material is actually going away from the sun. So sun is missing a lot of, or is losing a lot of mass. But we may think that 1 to 2 million tons every second means, oh, the sun will die soon. But for the case of sun, it is nothing. Okay, there is this mass is nothing when compared with the entire mass of the sun. Okay, even if this happens, it can last even more than some septillion of years. Okay, so now another thing, that is sunspot. This sunspot is even visible right now. Sometimes it is even visible to the naked eye. If you go to beach somewhere when the sun is setting, so during the sunset you can actually observe the sun as like this. And you, if you observe in this picture, you can see this some dots. These are not the any dirt or some dust particle on your screen. It is actually the dots on the sun surface. Okay, and they are called a sunspot. So why it appears as black? Because when compared with the other part, okay, so other part means this yellow part, the temperature of this yellow part is actually something around some 4,000, or so this is some 4,000 or 5,000. But at the same time, if you go inside that, here it is some 3,000 Kelvin. Okay, so there is a it is, the sunspots are less in temperature. That is why we are seeing it as a black space. Okay, even though it is looks like we say that it is low in temperature, but its temperature is actually 3,800 around. Okay, so even though it is lower in temperature, it is not that low. Even it is, even now it is of the in the range of 3,000s. Okay, and its lifetime is between some hours to few months. And there is an interesting thing, actually even Galileo did, that is so once you see a dot like this on sun, you can keep track of them. So it actually moves across the sun. So today if it is here, tomorrow it may move to the it bit forward, bit again, something like this. So that movement is happening because the sun itself rotates. Okay, So like Earth, Sun also rotates. But there is an interesting thing. The rotation of Sun, since Sun is not a solid thing like Earth or Mars, okay, it is something kind of a gaseous thing. Uh, it is made of gas or plasma, we call. So the problem is that different part of the sun moves at different speed. Okay, so here if you see the center part, it moves at some 25 days, it will make one rotation. So the center part will make some 25 days, and if you go to higher latitude somewhere over here, it will make some 28 days, and even higher if you go, it is something around 36 days, or at 80-degree it will go at 36 days it will. So different part of the earth, sorry, sun moves at different speed, but the earth is not like that. Imagine if earth is moving like that, and assume that this is my country, okay, so something looking like this, and if the different part of the earth is moving at different speed, initially it will look like this, but later what will happen, the center part will move like this and the remaining part will stay here. So completely the shape of the earth will be, or the continent, or will change suddenly. Okay, so and this kind of rotation of any gaseous things are called differential rotation. So that are the suns. And there is another feature that are called prominences. Okay, so they are sometimes called a filament as well. So prominences are also known as filaments. It's a large plasma. So what is plasma actually? So you might have learned three things. So the material can be seen as three types. So one is solid, okay, like the pen that you have, and liquid like the water what you drink. So that is liquid. And there is another thing which usually we cannot see if it is not colored, the air we breathe, that is in gaseous phase. Or we can say that the matter we can see as solid, liquid and gas, that you already. But apart from this, there are many other states of matter. So these are together called states of matter. What are the different states of matter? So it can be seen as solid, liquid, gas. And now there is one more thing that is called a plasma. Okay, plasma means they are actually, so when you see a if you have seen some electric spark, some blue colored thing from a Tesla coil or something like that, then that is actually a plasma. So plasma is made of, so what is inside that plasma? Plasma is actually ions or charged particles. So when you take an atom, okay, so if you assume that an atom is there, the center nucleus is positive and outside is negative electrons. Now if you remove one electron, then the charge of that atom will be positive. So when you take that positively charged atoms together and all the charged things like the protons, electrons all together, then that is called a plasma. Okay, so plasma is the collection of charged particle at high temperature. So sun is, we can say that sun is not just gaseous actually. So instead of gaseous, it is better to say sun is a plasma ball. Okay, because of the high temperature, everything is at ionized, or everything exists as different charges. Okay, so we call it as the sun a plasma. So the prominence is also the plasma that is actually making this giant loop. And why this giant loop is there? Yeah, if you do some experiment with magnets, so if you take a north and south pole magnet, the magnetic field or the force of magnets are actually distributed in a specific pattern, something like this. So you will do this experiment later in your school class with some iron filings and all. So it will make some filaments like this. So this is the path through which that force is acting, that magnetic force is acting. So similarly, sun is also magnetically so active. So those, through those magnetic lines, the plasma will arrange like this. Okay, so that is what is causing this prominence. And you can see that the size of earth, okay, when compared with the size of the prominence. Okay, so this is the size. And sometimes there is one more thing will happen, flares. That means some part of the this prominence and get ejected from that sun, and it is called the prominence. Okay, now we want to discuss how this energy is being transferred in a star, or generally in sun. Okay, now we can see, so in science, we say that there are three methods of transferring energy from one point to another. Okay, whether it is heat energy or any kind of energy, we can imagine like this. So, or usually for light. So, heat energy can be transferred, especially heat energy can be transferred in three modes. So, the first method is called conduction. So, even though these words are not familiar to you, all these things you know very well by your experience. Okay, so first is conduction, the second is convection, the third is radiation. So what is conduction? Okay, just leave what is conduction or what is behind that. So conduction is something so simple. If you take a spoon, imagine that if you have a metal spoon in your hand, and if you are holding it on one end and keep it on the gas flame or on a candle light, can you hold it for a long time? For sure you cannot, because after some time, it will take some time, that is the spoon at the near end, okay, or near the candle will get heated, and that heat will be transferred through that spoon, that metal spoon, and will reach your hand. Okay, then you will get that burning sensation, then you will leave that. Okay, you will stop that experiment. So this is a daily life experiment. There is nothing. If you go and touch on the when somebody is cooking, your father is cooking in the kitchen, then you cannot go and touch on the metallic handle. Why? Because it is conducting heat. So that is called the conduction method. Okay, now the next thing is convection. So convection is another interesting thing. Suppose if you're, again we can take the kitchen example. Suppose you have a vessel of water, okay, and we are giving heat. Okay, so we are burning or heating it anyway. Okay, we're using LPG or maybe using electric oven, whatever it is, we are heating it. So when it heats, what is actually happened here? It is not heating. Water is not getting heated by conduction. So it is full of water. Okay, so the bottom layer first heats up because it is near the heat source. Okay, here the heat source can be anything, so it is near the heat source. So this lower layer will heat first and it will move to the top. Now when it moves to the top, the next layer will come here. Again it will get heated and go up. Then again this cycling will happen. So it get heated and go up, and the cooler part will come down, then the cooler part will heat up. Then this is keep on happening like a cycle. Okay, this is how water is getting heated, the atmosphere is getting heated, all these things happening. That is called the conduction. And there is another thing called a radiation. So suppose there is a heater, electric heater is there in your home. Then if you stand near that heater, okay, you feel that heat. Okay, so that is not by conduction or convection. Where what is happening is the radiation. The light itself or the energetic photons is directly coming to your hand and it is being absorbed by your hand, and that is why you are feeling that temperature, okay, or that hotness. That is called the radiation. So these are all the different things: conduction, convection, and radiation. Now if you go to the case of sun or any star, in star and all there won't be any convection, any conduction at all. Okay, so conduction won't be happening. So in heat transfer there is conduction, convection, and radiation. I have explained all of them. But in the case of a star, conduction won't happen. What will happen there is the convection and radiation. So initially this is the radiation will happen, then after that there will be convection. So this is called the convection zone of the sun, and this is called the radiation. So from the core it starts at radiation, then after a certain distance, when it reach almost near the surface, it will become convection. That is why this zone of star is called the convective zone, and this zone is called the radiative zone. Okay, so this is how the heat transfer is happening inside a star or maybe inside sun. Okay, and depending on the size and size of the star, this radiation and the convective zone will also change in size. Okay, so that is how the heat transfer is happening. Now the next question, we already said that there is lot of temperature is there, there is so much heat is there. So how the sun getting heated, or what is the source of energy? There should be something there to give that heat or light Okay, so there is heat energy, there is light energy. Anyway, we are receiving light energy here. How, what is the source of that light? Okay, so usually if you want to get something, uh, we have to heat something. Okay, so you need, usually if you want to heat an electrical oven, then you need some electrical energy. There is no electrical energy in the sun, or is there? I don't know, there is any that kind of things are there. So people actually thought the same thing. What is happening there? How the sun get this much amount of energy? And people thought different things. So the first thing, okay, they thought so simply, there is nothing. This, just assume that some coal is there, or some wood or logs is there, and it is getting burned there. Okay, someone is burning some charcoal there. Assume that some charcoal is being burned at the sun. So charcoal burning means it is a chemical reaction. What is called? It is called a chemical reaction. So all the burning that is happening in is actually all of them are actually burning. So LPG burns, then petrol burns, diesel burns, gasoline burns. So we know that all of them. So people thought that maybe some coal or some gasoline. What if it is happening there? Okay, that is one thing that they thought. And there is another thing that can cause heat energy and light, that is gravitational energy. Because when there is something, so assume that the sun is so big, and because of gravity it is getting compressed. When something is getting compressed, it heats up. So is it the gravity is causing this heating up of the sun, and that is why it is giving off light? So these are the two questions we had initially, scientists had initially, and they checked whether it is right or wrong. And this is how the calculation, don't bother about this calculation. I will explain the I'm not going to explain the calculation, but see that when they thought that if it is the chemical energy is being, or the is some kind of burning, like the burning of gasoline or burning of coal is happening at the core of the sun, then the sun can only last up to 1660 years. Then the life, so scientists assume that chemical burning is happening, or some kind of wood is burning there, some logs are burning, or some gasoline is burning there. Then they assumed like that. Then they calculate, if that is some gas is burning there, then how long the sun can last. And they made that calculation, and they got it as 1660 years. Okay, so you already know that even the calendar itself is more than 2000 years old. So anyway, it is not that. And apart from that, when they analyzed different rocks on the surface of earth, the earth's surface, even they are able to find some rocks of age some 4 billion years. Okay, so since sun is the planet should be formed along with the sun or just after the sun, then it is not possible. At least the sun should burn for some 4 or 5 billion years. But how about this 1660 years? It is impossible. Then they thought of gravitational energy, and they found that if the gravitational energy, or the gravity is making that energy for burning, then the life of the sun will be million years. It is better than the burning of gas or coal. So when they assumed the gravitational energy, it is something about the 20 million years. But again, we know that the age of the solar system is at least some 4 billion years. Okay, from the Earth observation, we know that. So from that, they again got it as, again it is wrong. So then what is that? It is not gravity. It is not. So any kind of other energy sources won't work there. Okay. Then comes the simple equation of science, or the most famous equation of science. Okay, I don't know whether you have seen this, and hopefully I haven't written the name of this person here. How many of you know who is this? Can you put in the chat who is that? Yeah, Albert Einstein. Everybody, that is Einstein Baba. That's cool. Okay, that is Einstein Baba, you can see, or it's Einstein. There is no need to explain about him, especially he's so famous. And his most famous equation, okay, and it is not just his most famous equation. This equation is called the most famous equation in the world. Okay, So even though we don't even in my school classes, I know this equation even without knowing what are the meaning of this E, M, C or anything. I don't know any of them at that time, but I know this equation. So that is the importance, or that much popular this equation is. And this equation is what is behind the story of the energy generation of star, or the reason. Okay, now let's see what are these things. Okay, so the left side, this E means energy. Okay, so E means energy. So energy is equal to M means mass. What is that? Mass or weight, you can imagine. Okay, how weight, what is the mass of that object? How much kilogram is it is, or how gram it is. Okay. Now the next thing is C. C already we mentioned yesterday. C is the speed of light, 3 into 10 to the power 8. Okay, or C square means you have to multiply C 2 times. Okay, so this equation can be written as energy is equal to mass into C, or mass into speed of light into speed of light. We have to multiply 2 times. So the meaning of this 2 here, that means you have to multiply C 2 times. Okay, so if it is some 3 4, okay, 3 power 4 or 3 raised to 4, that is the meaning is 3 into 3 into 3 into 3. Okay, so the repeated multiplication can be written like this. Okay, that is the idea of exponentials. Okay, just leave that. Anyway, this is the equation. So what is the idea? What it has to do with the stars? That is our question. So here you can see that mass can be, okay, so the mass can be converted into energy. Okay, so which mass is that? Which mass is being converted into energy? So once again, we are going to atoms. Okay, now that atom consists of what are called, there are nucleus. There is a nucleus which consists of proton and neutron. We have seen that zoomed in picture and all, and around that there are electrons. Okay, now in this case we are only taking that nucleus. Just get up, take that nucleus. So now we are concerned not about the electrons. But why? Because in a star especially, these electrons won't be there because of high temperature. All the electrons will be gone. Okay, there what remains is only the nucleus. So we will be discussing only about the nucleus. Now here this is the carbon nucleus. That means it consists of how many positive? Red means that is protons. So how many protons? 3 protons are there. How many neutrons are there? Yeah, it is 3. So now let me ask another simple question, not regarding anything nucleus or anything. Just leave it. Okay, just forget it for some 2 or 3 minutes. I am taking 3 red ball. Okay, 3 red ball and 4 white ball. Okay, I am taking 3 red ball and 4 white ball. Okay, now the weight of red ball, okay, what is the weight of red ball is 1 kilogram. Okay, the red ball has a weight of 1 kilogram and the white ball has a weight of 2 kilogram. Assume that white ball has 2 kilogram. Now what is the total weight of this 3 red ball and 4 white ball? Can you calculate it? It has nothing to do with this proton or anything. Just tell me. Yeah, 8 plus 3. Yeah, so 3 red ball means 3 into 1 kilogram, that is total of 3 kilogram, and 4 white ball means 4 into 2, which is equal to 8. So the total is 8 plus 3, that is 11 kilogram. No doubt at all. Okay, you all know that mathematics. It is not 15, it's 11. Okay, now let's take, I am going to take those, these are all separate balls. So I am keeping it in a different boxes. There are different balls are there. Now I am taking all this. How many balls are there in total, including the red and white? It is 7 balls are there. I am taking all those balls and making it together, keeping it together. Okay, so closely. Then what will be the total weight? So now these 3 red ball and 4 white balls are sitting separately. Now I made it, I am keeping it so close and together. Now what will be the weight of the 7 balls? It won't change. It won't change. Yeah, exactly. Again, it is 11 kilogram. So if it is 11 kilogram here, if nothing happened to the ball, then it should be 11 kilogram. That is fine. That is the real life case, and we are all have this experience. Okay. So if you buy some 5 kilogram, 10 packets of 5 kilogram thing, then even if it is separately, it should be 50. Even if it is together, it should be 50. That is the basic mathematics. We know that. But the problem is that if you go inside the atom, and especially if you go to the nucleus, this mathematics won't work. Okay. So let's see that. Okay. Now let's take the carbon again. So the carbon consists of 6 neutron and 6 proton. Okay, and the carbon nucleus is these 6 neutron and protons held together. Okay, so you can imagine it as ball. Okay, so this red balls are there, blue balls are there, they are separate, and here it is together. Okay, so usually the mass of this should be equal. Okay, if it is usual cricket ball or something like that, then the mass should be equal, no doubt in that. But if you take the case of the protons and neutrons, and if you make a nucleus out of it, the individual, when it is separated out, it is more massive, and when it is together, it will be less in mass. So something like, just imagine, when the balls are separated, it is 11 kilogram, and when it is together, it is 10 kilogram. Okay, how puzzling it is, just imagine. Okay, so usually in real life there is no such examples are there, but inside the nucleus this is what is happening. So if you take the protons and neutrons separately, it will weigh more than when it is taken together as a nucleus. So some mass is missing somewhere. Okay, that means when it is becoming the nucleus, some mass is missing, and that mass is actually used to hold the nucleus together. Just leave that. Okay, that is it. Now we can do what is the purpose of this here. Okay, and that difference in mass is called the defect in mass or mass defect. Now let's do another example. Here I am taking 4 protons. Okay, you can see 1 proton here, 1 proton here, 1 proton here, and 1 proton. Okay, and they are all hydrogen nucleus or proton. We can call it as the hydrogen nucleus or simply proton we can call. And I'm adding all of them together. Okay, and each of them has a mass of some unit 1.0. So just leave this number, don't worry, I will do the calculation, and you get it as 4.0313. Okay, no problem. Their total mass, it is something like the calculation that we did for the ball. Okay, now we are combining it to form a nucleus, something like there are methods, or when they combine, actually this P can be converted, or this blue can be converted into green or to neutrons. That is not a problem, but it is actually taking it together. When it is combined together, it will weigh way less than that. So when it is added, you can form this, but then it weigh less. How much less? So tiny. So if you take the difference, it is just 0.0287. So anyway, just understand that when some hydrogen nucleus are separated, it weighs less than weighs more than when it is combined to form a helium. Okay, so some mass is missing. That mass is being converted into energy. So along with it, that missing mass will be converted into energy. So where is that missing mass? That missing mass is converted into energy according to that equation. Which equation? That mc into c. So that m you can put here and multiply it with the c, again with a c, and you get an energy. Okay, that calculation is not that simple like this. You need to do some other mathematics. Anyway, that is simple idea is that, so that mass is being converted into energy. So that is how the energy generation in stars is happening. Hydrogen nuclei are coming together and what's to say coming together, and they are fusing. Okay, hydrogen is getting fused. What is hydrogen? For more accurately, hydrogen nuclei, okay, getting fused to form helium nucleus. along with energy. So this is the energy generation method in stars. So what is that? It is fusing, or we call it as fusion. We call it as fusion, or hydrogen is fusing. Hydrogen fusion is the energy generation in stars. Okay. So this is how we calculate all these things. So just leave that calculation. So this is the same principle that is happening in a hydrogen bomb. Okay, atom bomb is also working on something similar, but there the reaction is something called fission. Okay, but in a hydrogen bomb, what is happening is an explosion. But in the case of a star, the star doesn't explode like a bomb. Why? There is some another force, that is gravity. But anyway, just leave it. Okay, this is the actual reaction happening. Uh, just leave that reaction and all. So but the star doesn't explode like a bomb, even though energy is being generated. Why? Because the gravity is actually keeping it together. So there is heat energy coming from the center, it is going outward, but at the same time gravity is pulling it inward. Okay, gravity is attracting it together so that it will stay stable. Okay, that is why a star doesn't explode. So we will learn more about that, what will happen if the energy is being missed there, or what happens when it run out of energy and all. Okay, that we will learn later tomorrow, especially when you discuss about the death of a star and all. So that's about today.